The essential complexity that arises as we move from single input to multiple input production is that once we have more than one input, there's more than one way of producing any given level of output without wasting any input, or more than one way of technologically efficient production. For any given level of output, we can produce that level of output with any combination of capital and labor that lies on that output's isoquant, without wasting any input. But just because something doesn't waste inputs doesn't mean it's economically efficient. Economic efficiency requires that the output is produced in the least cost way. Thus, while it's certainly important not to waste any inputs, it's also important to think about how much the inputs cost, and therefore where on the isoquant we should end up if we're going to produce a certain level of output. Producers don't have budgets the way that consumers do, because producers generate their own revenues with which they cover their costs. However, we can still imagine what it would be like for a producer to face a budget. Suppose, for instance, that the wage is $20 per hour and the rental rate is $10 per unit of capital, and we gave the producer enough to spend $300 on production. The producer would then be able to hire either 30 units of capital at $10 per unit, or 15 labor hours at $20 per hour, or something in between. The slope of the resulting budget constraint is then minus 30 divided by 15, or minus 2, which is equal to minus W over R. This should seem familiar from consumer theory, where the slope of the budget constraint was equal to minus the price of the good on the horizontal axis divided by the price of the good on the vertical axis. Here, the price of the input on the horizontal axis is wage, and the price of the input on the vertical axis is the rental rate. For producers, we call this hypothetical budget the isocost that corresponds to spending $300 on inputs. If the producer wants to produce 100 units of output, he can do so with any input bundle that gets him to the isoquant that's labeled 100. He can certainly do that by spending $300 along the blue isocost, but he can also do it by spending less, and he'll therefore shift to the smallest possible budget that can still reach the isoquant for 100 units of output. That smallest budget is the isocost labeled C equal to 200. In other words, he can produce 100 units of output by spending $200 along the green isocost at the production plan A, where he uses 5 units of labor and 10 units of capital to produce the 100 units of output. In panel B, we similarly show that he can reach the isoquant for 50 units of output in the least cost way by using the input bundle B, 2.5 hours of labor plus 5 units of capital, and thereby spend $100. Or he can spend $300 to reach the output level 150 in the most efficient possible way by choosing the input bundle C of 7.5 hours of labor and 15 units of capital. We can then transfer the information from panel A by noting that the producer can produce 100 units of output by spending $200, and we can transfer the information from panel B by noting that the producer can produce 50 units of output by spending $100, or 150 units by spending $300. The points A prime, C prime, and B prime then represent the least cost or economically efficient ways of producing these three levels of output, given that the wage is $20 per hour, the rental rate is $10 per unit of capital, and the underlying technology is as represented by the isoquants in the top panels. Connecting these, we then get an estimate of the firm's cost curve at the current wage and rental rate. In other words, the curve that tells us for any given output level how much in cost the firm will incur, assuming it is producing in the most efficient way. It's exactly like the cost curve we had in Chapter 11, only in Chapter 11 we didn't have to think about the difference between economic and technical efficiency. In Chapter 11 there was only a single input, and so there was only one technically efficient way of producing any level of output, only one way of producing without wasting inputs. In other words, in the single input model, the technically efficient way of producing is also the economically efficient way of producing. Here, however, we have many different ways of producing in a technically efficient way along an isoquant, but only one of those, for each isoquant, is economically efficient, and we therefore had to find that economically efficient input bundle for the different production levels before we could plot the cost curve. Once we have the cost curve, however, deriving the marginal and average cost curves is exactly the same as it was in Chapter 11. For the average cost, we simply divide the total cost by the level of output, and for the marginal cost, we simply look at the slope of the cost curve. The slope of the cost curve here is 2. Since the slope of the cost curve is constant, the marginal cost is constant, and the average cost is equal to the marginal cost, because at each of the output levels, if we take the dollars on the vertical axis in panel C and divide by the output level on the horizontal axis, we also get 2. The reason for the constant marginal and average cost curves in this animation can be found in our underlying assumption of a constant returns to scale production technology. You can see that that's what we've assumed by looking at the production plans A, B, and C in panels A and B. At the production plan B, we're using 2.5 hours of labor and 5 units of capital to produce 50 units of output. At production plan A, we're using 5 hours of labor and 10 units of capital to produce 100 units of output. In other words, by doubling the input bundle, we've doubled the output we're producing. When we then increase the input bundle by the same increment again, we again see an increase in output of 50 units. Thus it never gets easier and it never gets harder to produce, resulting in a constant slope for the cost curve and a constant average and marginal cost. We'll see in the next animation that as we change the assumptions about the underlying production technology, the shapes of the average and marginal cost curves will also change.